Nissan is developing various technologies to enrich people's lives. In Nissan Tech Talks, our tech developers talk about how our technologies work and the value they bring to customers. Nissan Tech Talks. Hello, I am Ryozo Hiraku, an expert leader in powertrain systems at Nissan. Today, I'm here to talk to you about our newest electrified technology, e-4ORCE. e-4ORCE is twin-motor-driven, all-wheel control technology developed by Nissan. We see e-4ORCE as an evolution of the car itself, rather than an evolution of all-wheel drive. Most people think that all-wheel drive is for snowy or rough roads. But e-4ORCE is for more than this. Of course, e-4ORCE performs well on rough roads and with high-powered cars. But we want to bring benefits even on ordinary roads. We want to see how far we can evolve the car itself. e-4ORCE delivers value in three ways. As I said before, all-wheel drive has mostly been used for rough roads and snowy roads, but e-4ORCE delivers value beyond that. First is steering that responds as you want. The motor's high response and high output helps to considerably improve stopping and turning. We want to make driving easier and fun. For example, normally when you turn the steering wheel, the vehicle doesn't always turn the same amount. The response might be delayed, or the turning speed might change depending on the road surface conditions and speed. Ordinarily, drivers correct this without realizing it. Because of this unconscious extra effort, driving can become tiring or difficult. But with e-4ORCE, the car makes the corrections with few or none needed from the driver. This is the value it brings. Second is driving comfort. We aim to make everyone in the car feel comfortable. For this, we have a control system that reduces unnecessary vehicle shakes. For example, usually when the driver steps on the brakes, it causes occupants' heads to move forward. The car can swing sideways, back and forth, and in many other ways. But by precisely controlling the motors, the system can maintain a flat vehicle position. The result is more comfort and enjoyment for all. Third is the virtue of all-wheel drive itself, which is safer driving in a variety of road conditions. This is aimed to deliver the peace of mind that comes from being able to drive on rough, snowy, and slippery roads without being nervous. These are the three values we aim to bring with e-4ORCE. Before I talk more about e-4ORCE, let me cover some related points. The first is the all-electric Nissan Leaf, and the second is e-Power. In 2010, Nissan introduced the world's first mass-market electric vehicle, the Nissan Leaf. EVs are promoted as environmentally friendly, but that is not enough. We envisioned the Nissan Leaf as a next-generation car, not necessarily just an environmentally friendly one. If a product is environmentally friendly but not fun to drive or is boring, it will not be accepted as a next-generation product. We approach the Nissan Leaf with this mindset. As a result, the instant acceleration response and the driving force of the motor have earned a considerable reputation. And now to the second point. Following the Nissan Leaf, in 2016, we launched a system called e-Power. e-Power is a form of series hybrid. While conventional hybrids are environmentally friendly and fuel efficient, they are not necessarily thought to be fun to drive. When we developed e-Power as a next-generation car, we had no intention of making a car that was just fuel-efficient and not fun to drive. So we chose a series hybrid system, a hybrid that uses the electric motor solely for propulsion. With a 100% motor drive system, we were able to offer a feeling very similar to the fun of driving an EV. The third is all-wheel drive. All-wheel drive is recognized for its ability to perform under special conditions when the need arises. However, our next-generation all-wheel drive e-4ORCE has been further developed as a motor-driven system. And as I said earlier, we aim to evolve it not only as a motor-driven all-wheel drive, but also as an evolution of the car itself. We wanted to break out of the conventional all-wheel drive value system. We combined the motor control technology developed for the 2010 Nissan Leaf, the all-wheel drive control technology we use on various vehicles, and our expertise in chassis control. We merged the technologies and expertise to create the vehicle's own behavior. The result, e-4ORCE, is designed to provide added value to all users by precisely controlling the driving force of each wheel. How does e-4ORCE work? And what kind of performance brings value? Of course, the basic functions of a car are driving, turning, and stopping. In the past, the engine generated the power, which was mechanically distributed, controlled by the brakes, and then the steering wheel. However, with motor-driven all-wheel drive, we can control driving force much more precisely. The result is three new kinds of performance. The first is regenerative braking, which allows the deceleration of the car to be controlled by the motor. In the past, braking was controlled by hydraulic pressure. With the replacement of hydraulically controlled brakes with motor regenerative brakes, we can control deceleration force in a very fine-tuned manner. For example, you want to stop on a very slippery road with an icy surface. Situations like this are quite common. When you want to control the vehicle speed on a very slippery surface, the braking force will cause the wheels to lock up or for the car not to decelerate as much as expected. However, with regenerative braking, the car instantly calculates how much deceleration force it can provide and controls the deceleration force in response to driver input. This is not something that can be done by just anyone with any motors. Motor control is quick, but quicker response can lead to issues. For example, when you increase the response of the motor and quickly generate driving force, it can cause vibration that ultimately goes to the wheels. This is because there is a component between the motor and the wheels, and because of the rigidity of that component, it is difficult to synchronize them completely. The faster you operate it, the more it vibrates. Cutting-edge technology is required to eliminate these vibrations, and Nissan's technology does it well. Generally, to avoid vibration, the torque should be started up slowly. By doing so, it will not vibrate. However, the motor is highly responsive, and we want to make best use of that. Our motor vibration suppression means it does not vibrate even when the motor is started up quickly. Regenerative braking has been known for a long time, and our motor control has developed it to a high level. But controlling pitch and yaw is something that no one thought was possible with a conventional powertrain. Pitch is forward and back movement of the vehicle body. For example, when you brake, the vehicle body pitches forward. When you accelerate, the vehicle body pitches back. Conventionally, this was determined by the geometry of the car, such as suspension and weight distribution. But e-4ORCE alleviates this problem to some extent by controlling the powertrain. More specifically, pitching during deceleration is suppressed by changing the distribution of the deceleration force in front of the motor and behind it in real time. It is not only the pitch itself, but also the rate, the speed, and the center of the rotation that are controlled at the same time to decelerate in a way that helps maintain comfort for the occupants. And the third one is yaw during cornering. As you might imagine, this is easier to understand if you compare a rear-wheel drive car with a front-wheel drive car. When a rear-wheel drive car turns on a slippery road surface, the rear wheels will slide and cause the car to change direction, which is called oversteer. But in a front-wheel drive car, the front wheels will start to slide, causing understeer. The reason for this is that each drive wheel has its own limit of grip, which varies depending on which direction it is coming from the back or from the front. If the driving force is distributed to all four wheels, the car can be driven very smoothly. For example, when you want to turn, it is easier if you push the steering wheel forward. When you want to bring the steering back to center, you pull it toward you. Through accurately sensing steering, acceleration, braking, speed, and other factors, e-4ORCE understands whether the driver is trying to turn or bring the steering back, and then distributes the driving force to steer the car according to the driver's intention. The automotive industry is transitioning from gasoline and diesel vehicles to motor-driven vehicles and EVs. It is a once-in-a-century transformation, and e-4ORCE is part of it. When cars with an internal combustion engine are replaced by cars with an electric motor, what should we think? Some say they want to make the transition without any sense of difference. However, at Nissan, we are trying to create the next generation of cars. We want to emphasize the difference and for it to be experienced as an improvement. So, we want people who used to drive gasoline cars to get into an electrified Nissan car and say, "This is different. This is a next-generation car." Our goal is for customers to experience a positive difference, rather than no difference. e-4ORCE is an all-wheel drive technology, but all-wheel drive has conventionally been used for special situations. e-4ORCE, however, is not for special situations, but for everyday use. We want customers to feel the benefits of e-4ORCE even when driving normally on a normal road. Nissan's electrified technologies continue to evolve. We hope you will continue to look forward to the latest from Nissan.